Hello, everyone. In today's video, I will finally show you how to connect body rigging and head rigging. In fact, connecting the body and head is very easy. However, there are additional minor details that need attention. So today's video might be longer than the others, but it includes very important content, so I believe watching it to the end will be very helpful for you. First, you can delete all the meshes except for the head meshes. Make sure to keep the body and head meshes from the previous body rigging lesson. These will be needed later, and I will explain why when the time comes. We will use the MetahumanSet tool to connect the body and head, just like before. Now let's import the entire head rigging that we created last time. Make sure to import without attaching a namespace. Once the head rigging is imported, you will notice that the joints from the spine downwards do not align. To connect these to the body joints, click the Connect Head Joints button. This way, the head joints will naturally connect and move well when various shoulder-related joints are moved. Let's temporarily turn off the combined LOD 0 mesh, but don't delete it. Great, it's connected well. The facial rigging also moves well as we adjusted it last time. Here we can see the morph we adjusted previously. Last time, we only applied the morph to the left side, right? Now let's automatically create and apply it to the right side as well. Opening the DNA editor in this current state won't load correctly because names that overlap with body joints, like those from the spine, exist in the scene. To load DNA while connected to body joints, we need to temporarily attach a namespace to the head joints. Click Make Head Namespace to add a namespace to the head joints. Then reopen the DNA editor or refresh, and the namespace will be automatically recognized. In this state, load the DNA of this character. Alright, since the morph is already applied to the left side of the mouth corner, let's move to the right pose. We currently only have the morph for the left side, right? Open tunaUtils and then open Mirror Shape. This function requires the original mesh to be available. The original mesh is the default state of the face, without any movements. Let's copy this default state of the face and change its name to something unique. Register the original mesh and select the morph we have. Then, click the Execute button. Now, you should see that the morph has also been created for the right side. Next, make a facial expression on the right side and observe the changes in the wrinkles. Select the item in the related blend shape. Choose the right morph. Ensure the invert shape option is checked, and then click Change Blend Shape. Now that we've successfully applied the blend shapes, I want to show you something important. Let's raise the character's arm. Do you see the gap forming between the head mesh and the body mesh? This gap occurs because the skin weight values are not matching perfectly. Even when you lift the clavicle, the same issue arises. Now let's turn on all LOD layers. Keep only LOD 7 enabled for the head and disable the other LODs. For the body, enable only LOD 3. Even with no movement, can you see the gap between the head and body meshes? This kind of issue becomes more noticeable as the LOD level decreases. For instance, with head LOD 5 and body LOD 2, the misalignment is still there, right? This is why you should never go with the default LOD meshes and skin information transferred initially by the DNA editor. This mismatch must be corrected for each LOD level to ensure the meshes align perfectly throughout all LODs. So, to address the skinning data issue, let's first replace the skinning data. Open the Auto Skin Load under the subtools in the Metahuman set. Since we've already applied this correctly for the body, we'll focus on the head only. Before applying the skin, make sure to remove any namespace attached to the head joints. After removing the namespace, click on Apply Skin. This process might take some time, so we'll skip ahead in the video. Once the skinning is applied, you'll notice that the gaps are no longer present, unlike before. This step ensures that the head and body meshes are properly aligned and follow the same skinning values. So, how do we solve the issue of mismatched body and head base meshes at lower LODs? To fix this, we need to swap the head mesh with a properly aligned mesh that matches the body. Open the tunaUtils tool. We'll use the prepared meshes to replace the current ones. First, select the prepared face mesh. Then, select the target face mesh corresponding to the LOD you want to change. Click Execute under Change Shape to replace the mesh. If the mesh already has skin data, tunaUtils will back up the data. Just ignore this for now. Proceed with the replacement. All right, let's take another look. Head LOD 7 and body LOD 3 match correctly, right? Since we properly applied the skin data earlier, the skin matches as well. Head LOD 5 and body LOD 2 also match correctly this time. I'll go ahead and delete the automatically generated backup data. Now we'll apply the material to the face. Go to the subtools and open Auto Materials. Then open the Hypershader and use Edit Delete Unused Nodes to remove any nodes that are not in use. Next, enable Mesh Warp, and I'll bring in the ADA template briefly. By bringing in ADA, all the correct materials related to the face have been loaded into the scene. If you see names in the scene that match the names shown here, you can click Apply. Once the application is complete, you can delete the ADA template that was loaded earlier. It has been applied very well. All right, now we are going to set up the LOD group. Setting up the LOD group will make it easier to import all the LODs into the engine at once later. Both the head and body will identify their parent groups to automatically match the LOD group. If the name of the topmost group is different, please make sure to match it exactly as shown in the tool. Once the LOD group is applied, you will see that as you zoom out on the screen, the LOD will automatically change to lower quality levels. Now, there is one more thing we haven't done yet. Some head joints are linked with the body joints and were previously adjusted to match the body. Since the transform values of the head joints have changed, we need to save these changes back into the DNA. Before that, let's create a namespace for the head joints. As I mentioned earlier, if the head joints are in the same situation as the body joints, this step is necessary to be read correctly by the DNA editor. Load this character's DNA and go to the Geometry tab. In the LODs section, click on All, and you will see the spine joints under the Init Joints section. However, if you click on LOD 0, the spine joints are not visible, right? This shows the joint information skinned for each LOD of the head mesh. We will select all, set the output path, and then click on Break Joint Connection. But since we want to save the current state, click Save Current Joint Init Data directly. It will ask if you want to save the current mesh state, but since the mesh has not changed, you can click No. If you had moved joints like teeth and changed the mesh, then you would need to click Yes in that case. Now let's delete the namespace since we no longer need it. To ensure this character can be properly exported later, we need to make sure the joints from the root to the spine are created to match the body joints. The body joints have all the joints from the root to the spine, but the head joints are missing a few, right? In such cases, you can click on Make Root Joint for a head joint. This will automatically create the missing joints and ensure they follow the body joints exactly. It looks like the control board did not follow along. In this case, increase the face GUI follow head value. If it starts moving strangely, just keep this value increased and go to the subtools. Then click Align Facial Board under Other Tools. This will automatically align the control board with the head. Grab the yellow square at the center and move it slightly to the side to leave a small offset. Now everything follows well. Excellent. Now it's finished. At least within Maya, all the work to convert this character to metahuman rigging is complete. However, for those who might want to apply this to an original character with a completely different topology, I'll include a few tips as a service in this video. Open the hypershader and clean up any unused nodes. It seems the body texture is not displaying correctly because this character has two UV sets. So let's check the UV sets. Copy the well-unfolded UV set to the other set and delete the unused UV set. First, open tunaUtils. Set the LOD group to show only LOD 0 and hide the others. Now select the combined LOD 0 mesh. Then select the original character body mesh and click Execute to copy the skin. Next, do the same for the other meshes, copying the skin from the Metahuman meshes to the original meshes for each part. All right, let's test a few functions. For the face, some areas might tear or appear strange. You will need to manually adjust the skin weights for these parts. This issue is especially noticeable when closing the eyes or opening the mouth. Let's open the lips. As expected, the skin is tearing where the upper and lower parts meet. This typical issue can be fixed relatively easily, though it involves some repetitive work. Select the surface area in question using Grow, Isolate it, and then copy the vertex weight from a desired area and paste it onto the problematic area. I'll speed up the video, so if you need to refer to it, please pause as necessary. By copying and pasting the skin weight values of vertex in this manner, you can quickly make adjustments. When copying skin to a completely different topology, some skinning modifications are always necessary. This aspect is no different from traditional rigging and skinning methods, so this video won't cover basic rigging and skinning techniques. Hope you're understanding. Great, it's looking pretty good now. Oh, when I lower the jaw, it seems that the skin on the teeth is not good. Let's clean this up as well. In cases where it's hard to make a selection, you can select the face using UV shell first. And then convert it to vertex mode to quickly paint the weights. These basic functions are manageable if you have a basic understanding of Maya's functionalities. In addition to this method, if the original character's face is symmetrical, you can refine the skin on just one side and then use mirror skin weights. It seems to apply well. This character appears to be symmetrical. Now let's see which meshes are left. We have some meshes related to clothing remaining. Let's go ahead and finish those up as well. Yes, I've applied the skin weights to all the remaining meshes. Since these original meshes also use the same Metahuman joints, you can export them to Unreal with the same structure as Metahuman. However, it is generally better to use the original meshes only for the clothing and use the newly created Metahuman model for everything else. Our new model has higher polygon count and better quality, and it includes all LODs. Of course, there might be cases where you specifically need the original character model, so we've covered these tips in the video. Thank you all for watching this lengthy video. See you in the next one. Thank you.